Hey Dr. Wilson, this is John Driscoll, and this is me and my group's regression analysis project number 2. So we decided to do Disney World in this project and to see which part of their income statement has the greatest effect on net income. So before doing this, we have to discuss big data because when gathering this data set, obviously it was not in this format. It's going to be messy. So what we have to do is we have to format it correctly. And so what we had to do is we had to get it in vertical format first and then fill in any blank cells that we have. So anywhere you're seeing a 0, we went ahead and filled that in to get, and all these numbers are in millions, and it goes from 2022 all the way to 2004 of their income statement. And so before we run our regression analysis on this, first we have to run a correlation analysis. So to do that, go here to data, and we're going to click data analysis. And we want to run a correlation. And so what we want to do is we want to run it from 2022 all the way to 2004, grabbing all of our data and using it. So after we ran that, this is the correlation analysis that we got. And so we're running a correlation analysis for a couple reasons. One is to find any independent variables that are correlated with the dependent variable. Another is to make sure that none of our independent variables are correlated with each other. Okay, so this is all of our years from 2022 through 2004. We also wanted to see, because of COVID affecting our income statement, we did want to see from 2019 all the way to 2004. We wanted to run it separately. So we went ahead, did the same thing, went to data, data analysis, correlation, and we went ahead and grabbed from 2019 all the way to 2004. That's excluding our COVID years affecting our income statement to see if we had a different result. So after we ran that, this is our correlation analysis that we got.
Okay, so here we have our first correlation analysis. This is the preliminary step to running a regression analysis. It's important to remember here that correlation does not mean causation. Correlation is simply determining whether a relationship exists between these variables and then inspecting the magnitude and actions of the variables. And so normally we will choose the independent variables that are highly correlated with the dependent variable, which is net income. However, you can see here that the two highest variables that are correlated with net income are also highly correlated with each other, which would result in a multicollinearity, and we don't want to choose those for our regression analysis. The variables that I selected here were equity and the income of investees, revenue and restructuring, and impairment charges. I could have used other income as a variable, however, I just wanted to see how the variables that I chose interacted with net income.
So today I wanted to talk about the regression analysis performed on the income statement of Disney World from the years 2004 to 2022. From this income statement, we were able to choose 3 variables. These 3 variables did contain the equity and the income of investees, revenue, and the restructuring and impairment charges. From this, we were able to run a regression analysis on these 3 variables, which contained a summary output. This summary output contained an R-square 42%. This meaning our equation is 42% viable to predict the total net income of Disney in a given year. Now, an R-square should usually be above 90%, but this could be from many things, from other stock, revenue, and expenses that Disney may hold. And a company like Disney may use data bridges, which would automatically import these documents to their company and would able to calculate the total net income a little bit better, which those may hold a little bit more weight in calculating the total net income. But as you can see as well, our significance F value was more than 0.05. This meaning, as well as you can see from our R-square, that our variables weren't that well in predicting our total net income. But when digging more into it, you can see that the restructuring and impairment charges and the revenue had a p-value around 0.05, except for revenue was just a little bit higher, but this means that these variables do have multicollinearity, which these 2 variables would be able to predict the total net income. So these variables do have more weight in the total net income prediction in a year at Disney World compared to the equity in the income of investees and the intercept. But these as well do have a bigger standard error and standard deviation. This meaning that their numbers could be a little off. As well, that could adjust their p-values and those could be a little bit lower. That does mean that those variables could have a little bit of multicollinearity related back to these, but in the variables of the p-value that we do have now, they are not multicollinearly related to each other besides revenue and the restructuring and impairment charges. As well, you could see from this, we were able to make an equation. This equation was the y-intercept plus variable 1, equity in the income of investees, variable 2, revenue, variable 3, the restructuring and impairment charges, to equal total net income. Now, these three numbers did hold a total net income of negative $226 million. Now, obviously, this is not normal for Disney, but as you can see, we did do our own calculations off of 5 million, 10 million, and 15 million. And as well, all of our calculations are done in millions. As we did this, all of our y-intercepts in these equations did stay the same, but our variables did change throughout, and this is why. We multiplied our 1.41 coefficient from variable 1 to our 5 million. Then we did that, the coefficient of 0.12799 to the 5 million, as well for variable 3 of the restructuring and impairment charges. We did the variable of 1.9708 ... to the 5 million. Now this did give us a total net income of $16,998,038. As well, we did the same thing for 10 million. We did the same thing for 15 million, just replacing that total income in millions. This gave us a total net income of $34,575,017. As well, 100,095 for 15,000. As you can see, those are higher numbers, but as well, since our R-square is only 42%, and there could be some standard error and deviation, that does mean our total net income isn't viable off of this, but there could be other factors played into this, like we said, and they could get this by data bridges, linking it and having the documents from other companies already forwarded to them, and this would hold more weight and be easier for that company to viably predict their total net income in a given year. But if we were run to another regression on the revenue and restructuring, now this would be totally different as those variables do have multicollinearity. But from what was given, our total net income would be a little off because our R-square is only at 42%. But the variables included revenue, restructuring, and impairment charges would be multicollinearity in guessing the total net income and hold more weight than the other variable chosen, the equity and the income of investees.
This is the correlation without the years 2020 through 2022 added. And as you can see, the revenues and expenses correlate more strongly. COVID being a very off year offset these numbers quite a bit from the previous discussion. As you can see, the only ones that don't really correlate on the income tax on continuing operations are other expenses, restructuring, and expenses. Everything else correlates nicely with that net income, which shows there's a good flow and the company is doing the best it can with its resources that it has, as they all correlate rather nicely with each other.
Hello, my name is Teresa Mize, and I'm going to be going over our regression analysis using the income statements from the pre-COVID years. But first, we need to look at our correlation and determine which independent variables that we're going to be using for this regression. So looking here, we see that revenue, expenses, and income taxes on continuing operations are highly correlated with net income. However, we can see that there is multicollinearity between revenue and expenses, as well as revenue and the income taxes on continuing operations. We want to avoid using variables with multicollinearity because we are not going to get an accurate result on our regression analysis. So therefore, we're going to use revenue as our independent variable. And after running our regression analysis, we get an R-square of 92%. And what that means is that our net income is dependent of revenue by 92%. Looking at our ANOVA table, we have a score of less than 0.05. What that means is that this was a good regression analysis. And also our p-value for revenue is less than 0.05, which again means that revenue is a good independent variable to use for this regression analysis.
Hello, today we're using our pre-COVID income statement to run our regression analysis. But first, I want to start by emphasizing why it's important to perform both a regression analysis for our pre-COVID income statement and our regular income statement over the last few years. As we know, COVID-19 is a systematic risk. It affects the overall market, not just one industry or just one specific company, which is why the net income for over the last few years after COVID-19 are different from our regular net income. As you can tell, here at the beginning in 2004, it's slowly increasing. And then after COVID-19, it suddenly falls. It's so that's why it's important to separate it. We want to do two different comparisons. Now, here, once we performed our regression analysis for our data for pre-COVID income statement, we find that our R-square has a high percentage, which means that this model is reliable when we compare how our outcome for our net income is affected by our revenue. We're going to use a simple linear regression equation since we only have one variable, which is our revenue. Here we have our y-intercept. In our formula, we use our y-intercept. We use the same y-intercept. It doesn't change. We keep it the same. And we add our y-intercept to our independent variable plus multiplied by our coefficient here, right here. We use the same coefficient, the same independent variable coefficient. We use the same one. However, we predict our net income by changes in our revenue. As a company, of course, our goal is to increase our revenue to increase our net income. Our estimated average over the last 5 years before pre-COVID is $58,500 right here. But we also want to be able to predict our net income if we get a lower revenue or if we attain a higher revenue. I wanted to test it in increments of $5,000. For example, in the lowest I put here in this test is $48,500. But we could also predict that we made higher sales, increasing $5,000, which would be $53,500. And it shows us our net income. Of course, the lower the revenue, the lower our overall net income. But this formula allows us to quickly calculate our net income depending on our revenue changes.